Hello everybody and welcome to the bonus lesson for the Solana SPL token. In this lesson you are going to learn how tokens, or more precisely how SPL tokens, Solana program library, work on Solana. As tokens are essential parts of all of the blockchains, I would say, so this is really important for you to know. At the start of this cohort, during the first lesson, I showed you how to create new token using the CLI command. However, in this lesson, at the end, we are going to have hands-on example of how to utilize tokens, mint accounts, and so on in the Solana program. So yeah, this can be really helpful also for you to use tokens in your Solana program submissions. This is everything from the introduction, and now we can continue to the lesson. Before we start, I would like to say that you should be familiar with the accounts and programs on the Solana. If not, then these were described in the previous lessons. More precisely, Solana Programming Model 1, I think, and CPI was described in the Solana Programming Model 2. So yeah, if you do not know what this means, what these terms means, then go watch the lessons first, and then you can continue with this bonus lesson. All right, so in order to explain SPL token, we created this picture. So you can see that we have multiple accounts here. The first one is token account. The second one is mint account. And the first one is system account, your regular wallet. Why system account? Because it is owned by the system program. And then on the right, these are also accounts, but executable accounts, so let's call them programs. We have token program, we can call it SPL token program, and we have system program. The fields in these programs are not that particularly important, but alright, we can see that they are both executable, so executable in token program and also in system program. What is more important are these free accounts. So if you would like to create new token on Solana, for example, you would like to create your own USDC or USDT. Let's create new USDC. The first thing that you need to create is mint account. The mint account is basically again the normal account on Solana, so you can see that it holds some amount of lamports, for example, in order to be rent exempt. It is owned by the token program, so in order to create new token or mint account, you need to interact with the token program, which will create this account, and then it will own the account. It is not executable, and you can see some additional common fields in the account, which are not particularly important here. What is important is the data field. So the data field actually holds information about the token. So as I said, we are creating USDC. It contains the mint authority. This mint authority is public key. It is actually address of authority that can mint new tokens, that can add new tokens to the circulation. It can be also none. That means there is no way to mint new tokens. So if you minted 1000 of tokens of USDC and the mint authority is set to none, that means no one on the Solana blockchain can increase the supply. So it will remain 1000. Then there is the actual supply field. So as I said, if you created 1000 of tokens, this will be 1000. And then you have, for example, the decimals, sorry. And this decimals logic is basically the same as for Solana. So in order to transfer SOL, there is no such thing as float, so you cannot transfer directly 1.5 SOL, but you are actually transferring Lamports. Solana has 9 decimals, that means 1 and 9 zeros of Lamports. And from the different perspective, let's compare it to the, for example, euro. So if you go to the store and you can see the price for some goods is 1.5 euro, if we compare it to the Solana blockchain, you go to pay for the goods, then it does not cost 1.5 euro but 150 cents. So that's the actual idea behind Lamports and SOL. If you transfer 1.5 SOL to your friend, you are actually transferring 1 billion and 500 millions of Lamports to your friend. Alright, so this was mint account. So once again, if you would like to create new USDC token, first thing you need to start with is the mint account, which holds the information about the token. So the decimals, the supply, and who can mint additional tokens. For those who don't know what minting is, so it is opposite of burning. So with minting, you can increase the supply of token. With burning, you can decrease supply of token. So that means if current supply is, for example, 0, you can mint 1000 of new tokens. Then you can, for example, burn 500 of tokens and so on. Alright, so you created the mint account, so you said all of the important information. I'm not sure if USDC has 6 or 9 decimals. I think it is 6. So we created a second USDC account because there is already one on Solana. So we created the second USDC, token, not account. We created the second USDC token. We set all of the required information, and now you would like to, the current supply is, for example, 0. So now you would like to mint yourself 1000 of USDC. Why not? So you did a great job, so you would like to take some spoils. For that purpose, you need account which name is token account. So mint account holds information about the particular token, and token account is used as something like vault to hold the tokens. The fields here are basically the same as for the mint account. So once again, you need to interact with the token program, which is the owner of the token account. But what is again important is the data field, which is this structure, which holds this structure called token account, and this structure holds information such as mint, owner, amount, and so on. But let's consider only these 3. So the mint field is important because it holds the address of tokens this token account or this vault actually holds. The owner is the public key or address of wallet which is owner of this vault, and amount is number of tokens this token account or this vault holds. So as I said, you would like to take the spoils and you mint yourself 1000 of USDC. That means this mint address is going to be exactly address of this mint account. The owner is going to be your Solana wallet because you are the owner. You minted yourself. If you mint your friend, then the owner is going to be your friend's wallet. And the amount is, in this case, 1000. And that's the idea of the token accounts or tokens on the Solana. So once again, you need to have the mint account and you need to have token account. what might be important to mention here is that the mint account for the regular Solana SPL token program, I'm not talking currently about the token 2022, which allows the extension and metadata. For the older version, you can see that there is no such thing like picture or description and so on in the mint account data field. That means these types of fields were not supported. So in order to create, for example, the NFTs or all of these meme tokens containing pictures, descriptions, and so on, there had to be like additional standard added to this. And this was, for example, created by the Metaplex, which, for your information, creates additional account for the mint account. This additional account is called metadata, and it actually holds additional information about the particular token. So for example, you would like to add picture to your USDC token, then you, for example, can interact with the Metaplex to create this metadata account holding this type of information. From the token 2022, this is supported, let's call it natively. So you can create metadata extension, and this metadata field can contain additional information about the token. So for example, description, picture, I don't know what else is there. I cannot remember right now. So yeah, but it allows to create add or create additional information to the token. So yes, this is everything. And one thing that I would like to also talk about is the associated token account, which is also really important on Solana, because sometimes I feel that a lot of people know about associated token accounts, but they actually do not know what it means for the token account to be associated. And it is pretty simple. That's why I'm sometimes surprised. So associated token account is basically, it is really simple, guys. Associated token account is basically the token account, as you can see here. It is the same, but the difference is in address of token account and associated token account. Because associated token account has its address deterministically derived, the address is PDA, has its address deterministically derived from the mint field and from the owner field. And the idea is that let's consider your friend. I didn't mention that you can have multiple token accounts. So if you have the USDC, you can generate new key pair. You can initialize on this address of the key pair token account holding bunch of USDC. Then you can generate new key pair, create a new token account holding another bunch of USDC, and with this approach you can have multiple token accounts. And now you have your third friend that would like to send you the USDC, and he doesn't know to which token account send you the USDC. So instead of having 10 accounts holding the USDC, you will have one account called associated token account, but the importance is the address. Because if you have 10 token accounts holding the USDC, you need to tell your friend to which address, to which token account to send you the USDC. However, if you have associated token account and the address of this token account is deterministically derived as a PDA, the friend knows the mint address because they know what token they want to send you, and they also know the owner because they know that they want to send the tokens to you. So, and when they know these two fields, they can derive the address by themselves. That means you do not need to share the address of the token account, but they can derive it and send the tokens directly to the associated token account. So that's the difference. All right, the associated token account has its address as a, or created, derived as a PDA from the corresponding mint and the owner of the token account. What might be confusing here is that you have two owner fields in the token account. This first owner field is actually owner of the account, and this second owner field is owner of the token account. So for example, you remove this data field, this owner field will still be here, and it can be, for example, system program, but this can be temporary. So as I said, if you remove the data field, this will be removed also. All right, to sum it up, so from this slide, what you should take is that we have token program on Solana. It is in the SPL. I will show you in the hands-on example. We have token program, which is kind of standard on Solana to create new tokens. This token program is owner over token account and mint account. Also over the associated token account. Then you have these two types of accounts on Solana, which are mint account and token account. Mint account serves purpose of storing information about a particular token. So you create a new USDC, it holds the supply, decimals, mint authority. There is also freeze authority, I think. I do not remember all of the fields, but I will show you in the hands-on example. There is the mint authority and some additional fields. And then on the other hand, you have token account, which holds the tokens. So in order to create new token, you create new mint account. In order to hold the tokens, you need to create token account, which is like vault. And last but not least, I was talking about the associated token account. So this is just the token account with deterministically derived address, or in other words, the address is derived as a PDA from the mint and the owner. This is everything from this slide. Now I would like to show also practical use cases. So let's continue to the hands-on example. Alrighty, so we are in the Docker image in the VS Code. And the first thing, I will build everything again from scratch. So the first thing is that I would like to initialize new project, new anchor project. So let's call anchor init with SPL example. While it will create the folder, I would like to show you the GitHub where to find the token program. This is helpful if you want to have a direct look into the source code, and if you want to understand what is actually happening in the token program. So firstly, let me increase the size. Yes, so we are in the Solana Labs, a Solana program library repository, and these are basically all of the programs available in the SPL. So for example, associated token account, memo, name series, and so on. But important is, if you scroll down to the token, you can see that there are multiple folders. You can see there is program 2022, and there is this alt, let's call it alt, but this is the older version of the token program. So if you click on it and open it, you can read some stuff here, and if you navigate to the source, src, so you can see the entry point, and what might be important for you is the processor. And if you open the navigation, you can see how all of the instructions are processed. If you call, for example, If you call process transfer, so you are transferring SPL tokens from token account to a different token account, you can see what is actually done within this instruction. And same goes for example, minting, burning, and so on. So this is the example, or this is, yeah, I wanted to show you where to find stuff about the token program. So feel free to go to the Solana program library GitHub repository and look into the source code. I also prepared, or I also opened the Explorer, so we will have a look into the transactions. Let me firstly restart the analyzer. All right, so let me close this, and yeah, so for the purpose of this bonus lesson, I already in advance prepared some kind of example for the hands-on of the SPL token program, how to interact with it, how to create new mint accounts from your Solana programs, how to create new token accounts, how to create associated token accounts, and so on. First thing that I would like to do is remove this. Give me a second. Oh, I'm on 29, so that is problematic because I want to be on different version. So okay, so I need to reinitialize the project because I was on the 29 and I want to be on 30.1. So yeah, just quickly, this is basically the same, but I wanted to turn the resolution to the false so we can automatically, or sorry, we can manually input accounts into the instructions. The second thing that I would like to do is to copy the airdrop and prepare it, and also I have some signers here, so let me also copy that part. And yeah, we can leave this there, and also let's let's call anchor build. So okay, it is building. All right, so regarding the program is going to be is going to have two instructions. The first one is going to be called initialize, and the second one is going to be called grab. The idea of this program is that in the initialize, we are going to initialize new mint, we are going to initialize new vault, and we are going to assign authorities over the mint and also over the vault, over the token account to PDA. So you can see that also PDA accounts, more precisely PDA accounts from your program, can be owners of, for example, the token account. The grab function, or sorry, the grab instruction is going to contain logic such that some random user can withdraw tokens from the vault that is owned by the PDA of your program. So let's continue. The first thing is that I would like to copy this and call it grab, and let's have a look here. Okay, it is built, and I almost forgot, we also need to include SPL as a dependency. So for that purpose you can use anchor SPL, use the same version, but also do not forget to include in the IDL build feature not anchor lang but SPL here. So once again, let me build the project. All right, it is built. So first thing, let's fill the context, and second thing, we will fill the instructions. So as I said, it is going to be called initialize, and the second is going to be called grep. And also we will use this grep as context here. So firstly, let's fill the initialize. First account that we want is signer. We also need to use this lifetime here. Alright, then the second account is going to be a data account of our program called vault data. So let me copy, or okay, I can create it from scratch. So abstract. This is not token account or mint account or whatever yet. This is just the regular data account of your program, and we are going to store creator of the token. You will see this in a later part of the hands-on example. Why is it important? All right. And we need to say that this is account, and also I would like to derive init space, so we can use this derived init space, so it automatically derives how much space we need for this struct. We will use it in the initialize context. All right, so the second account, and maybe let me increase it once more. The second account is actually the vault data account that I would like to specify here. So type account vault data. Let's fill the account constraints. First of all, this account is going to be initialized. Then we need to provide payer, who is going to pay rent for the initialization to store the data, to pay rent, to pay rent to store the data. This signer has to be, of course, mutable, because paying rent means his balance is going to be decreased, so the account has to be mutable in order to update the balance of the account. So mutable. We need to specify how much space we would like to allocate. So for this purpose, we need 8 plus, and now access the vault data init. Sorry, give me a second. Let me copy the constant name like that. If you hover over the field, you can see that we need also system program, because we want to create the account. So this is pretty simple. System like that. You can see we do not have errors anymore, but yeah, this is not everything, definitely. What I want to add is that this is going to have the address derived as a PDA, so for that purpose we need to specify seeds. And let me copy this from the example. So I just chose the vault data string as a static part, so it's up to you, but you can use also this one. And then the signer also. So for that purpose, like that. And we want to use canonical bump. All right. Currently, if someone calls the initialize instruction apart from that, it will print this message, oh sorry, this message. It will also create this type of account, because we have init here, the payer is the signer, then we have space. You may ask why we have this 8 plus something. This init space corresponds to number 33, which is actually 32 plus 1, because this is 8 bits long, so 1 byte. Pub key is 32 bytes long, so 32 bytes. So that means 32 plus 1. So you can see, if you hover over it, you can see 33. And this is because anchor discriminator. So this is security related, but if you have multiple accounts that have the same data length, that means, in your program that have same data length, that means they can be deserialized between each other. So in order to differentiate between the data field, anchor stores as first 8 bytes its discriminator. That means even though the fields are alright, it will each of the account will have its own discriminator. That means this account can be only deserialized into the vault data, as the vault data has different discriminator as, for example, some different account in our program, which we currently do not have, but this is just the security consideration. It is by default, it is mandatory, it is by default created, or I wouldn't say it is mandatory. You can definitely create account in a SIM in a different way, but yeah, it is definitely recommended. All right, let's proceed. Let's continue with the logic of creating the mint to create new token and creating the token account to store the new tokens. So for that purpose, let's have this additional account in the context. Again, this type of account, but what we are going to store within the account is mint. You can see there are multiple options, as we included the Anchor SPL. Do not work, or yeah, you can try definitely, but we are not going to work with the token 2022 yet. So just for this purpose, include the Anchor SPL token mint. Right? What I would like to show you, if you hold Control and click on the mint, you can see this is the wrapper from the Anchor SPL containing the SPL token state mint. You can find this in the Solana program library, repository that I showed you. And next, if you also hold Control and click on this mint, it will take you to the definition of the mint account. Oh, sorry, the struct that is stored in the mint account. And yeah, you can see the fields here. So the first is the mint authority. You can see this option. So if it's set to none, you cannot mint new tokens. You can see the supply, decimals. You can see if the account is initialized, and you can see also freeze authority. So this is just the description, or yeah, description of the mint account. So all right, I said we want to initialize the new token. So for that purpose, we would like to initialize basically new mint account. So what to specify here? Account. All right. We want to initialize this new token, this new mint account. So we can specify in it basically the same as in the previous type. Then we need to specify who is going to pay also the rent here, because we are again storing data on chain, and that requires paying the rent for that. So we need to specify the payer that will pay the rent here. So again, it can be signer, it can be different account, but in this example, the signer is going to pay the rent. What might be important here, interesting here is that the new mint, the mint account can also have its address derived as a PDA. For that purpose, let's define the seeds. For the static part, let's use, for example, mint. And for the relative part, I would like to use again the sign. Why not? And let's also use canonical bump. I have mistake here, like that. Okay. So we are just saying that we want to initialize the account, the payer is signer, and these are the seeds. Space must be provided. Actually, this is not true. We do not need to provide space, but we need to provide token program. Again, you can see you have multiple options. You can choose token 2022, but in this example, we are going to choose just the, let's call it old one. I do not like to call it old one because it is not that old, but let's consider that token 2022 is new version of the SPL token, so let's call it old one. Press enter. All right, and we are initializing the, why is not important, or this is not correct because we do not need to actually specify the space, because Anchor will derive this from, or Anchor knows this automatically because we specify that we want to create mint, so Anchor knows this. This error will disappear in a second. We are creating new mint account for the token. As I was talking about the example about the USDC, this is basically the same. So if I go to the mint account, you can see that, for example, the mint account or the token have some amount of decimals. So we need to specify some fields here. First of all, let's specify decimals. And for this purpose, when initializing mint, authority must be provided. Okay, so in a second. I was talking about decimals. I choose value 0 for you to also show you that it does not need to be necessarily 9, 6 or something like that. You can have also 0 decimals. That means you cannot send something like 0.5 tokens. You can send only 1 token, 3, 5, whatever, but not floating point numbers. And then we need to specify the authority, which in this case, I want it to be vault data. So this vault account holds some data in it, or will hold some data in it, and this vault data is also authority over this new mint. And you can see the space error is not here anymore. All right. We just specified logic in order to, or for creating new token, or in other words, new mint account. But we need to, or we want to store the token somewhere in some vault, which is called token account. So for that purpose, let's create new token account. Moreover, we will create associated token account for this purpose. Do not use account from the token interface, but we can use the regular old one token account. Again, you can play with that. Alright, and as I said, we want to initialize this associated token account. So for that purpose, again init, pair is again signer, and now we as we entered values that we would like to initialize in the mint. We also need to specify, we decided that this account is going to be associated token account. So as I was talking about this in the previous parts of the lesson, associated token account has its address derived from the owner and from the mint address. So for that purpose, we need to specify the mint address and also the owner. So this is going to be the same, but it is called authority, and the authority again can be PDA, so we will use the vault. You can see that we have error here, cannot find value associated token program, and that is because you need to specify also associated token program for the CPA that is going to be performed by the anchor in order to initialize the account and associated token. All right, and yeah, I showed you contents of the mint account. Let's have a quick look in the contents of the token account. So you can see again, Anchor has wrapper called token account over the SPL token state account. You can see this again in the GitHub repository. And in the token account, there is stored the mint address, owner, amount of tokens that it holds, and there is some delegation, there is some state, if it's native, so you can have wrapped sol as a SPL token, and there is the amount that is delegated and close authority, again option, and so on. All right, did I forget some account? I don't think so. So let's continue to the initialize, and greetings from, let's call it greetings from initialize, and remove this part and this part. All right. Okay, what we would like to do in this part. The first thing is that we just initialize the vault data specified here. So we need to fill these fields in the account. Then, then we created the mint account and the corresponding vault account. For that purpose, we would like to also mint new tokens into the vault. So we are also going to perform cross-program invocation into the token program that will mint new tokens to our vault. First of all, let's store the data in the vault data account. Like that. And also the creator. And the creator is the signer. Okay, so we just stored the data. Now let's mint new tokens. So for that purpose, we have this mint to method. You can see we have again multiple options, for example, also from the token 2022. But in this case, we are going to use this first one from the Anchor SPL token and mint2. Cross-program invocations were described in the Solana programming model too, so if you do not know what are we doing right now, check the lesson first and then you can continue here. In order to perform the CPI, we need to specify the CPI context and the amount that we would like to mint. So let's continue. Here you may be considering new or new with signer, but we need new with signer because here we specified that this new mint has the mint authority set as PDA, and PDA has to give approval in this CPI that yes, let's mint this amount of tokens. And in order to give permission or the approval as a PDA, you need to sign the CPI with the PDA. PDA do not have corresponding private key, so for that purpose we can use new with signer and specify the seeds that are used to derive the PDA. Why is this important? Again, Solana programming model 2, or important, why we need to, or why is it secure, for example, to use the CPI like that? Solana programming model part 2. All right, so in the CPI context, we need to specify to which program we are creating the CPI. So for that purpose, token program contains logic that allows us to mint new tokens, to burn, transfer, and so on. So that's why we need to perform CPI to the token program. You can see the token program is on the input here. Then we need to fill the accounts required for the CPI. There is structure from the token 2022 and again from the older version. So let's select the one from the older version. It is struct, so we can let it automatically fill the fields. Let's remove this part and give me a second. I would like to format it. Will this help? No. Okay, so I need to fill it, for example, whatever. All right, so first thing, we need to specify the accounts that are required for this instruction for this CPI. So the first account here is the mint. So we want to mint new tokens of this mint account. That means we need to specify the corresponding mint account. So new mint from the context on the instruction input and to account info. Here is also two. This is important because as I was talking about this in the previous parts, you need some token account to hold actually the tokens. So that's why we have the vault. That's why we created the vault in the instruction context. And here is the new vault. And last but not least, the authority, and the authority set in the context is the PDA, the data account. So vault data, and I do not like how long is the line, so never mind. Let me do this. I do not know why it do not want to format the source code, but give me a second, I will do it by myself manually. All right, and now the signer seeds. So as I said, we need to give the permission to actually mint new tokens, as the vault data address or the account is the authority over this, is the mint authority for this mint account. So for that purpose, let me copy the definition of signer seeds. So this was also in the Solana programming model 2 described. You need to specify the signer seeds, that is basically from which seeds the PDA can be derived. The runtime will automatically add the currently executing program, as one of the seeds is actually the program ID. Currently executing program, that means this CPI can be performed only from our program. And yeah, we have these two fields that we need to fill. Sorry, new data, like that, and the signer key. Like that. And okay, so we have specified this, and we also need to specify the amount. So for this purpose, let's mint 1000 of tokens and propagate the error. All right, it looks like it is correct. Let me do it like that. Let me build the project. Okay, now once again, if you would like to have the second look, so first of all, mutable reference over the account, so we can update the field, so more precisely bump and the creator, then just initialize the bump and the signer key or create new instance, use these instances for the signer seeds, then create cross-program invocation context for the token program. Instruction is mint2, so we are minting to the from the of the freshly created tokens to the new vault, and authority is vault data, so the PDA, and the signer seeds for creating the PDA. I would like to double check this part. Yes, this is the same. And then we perform the actual function or the instruction. All right, let's now go to the tests. So let's call the first one initialize based on the instruction name. And first thing that I would like to do is to airdrop. So we are airdropping to the signer 1. And the second thing, let me copy this part. This is the same as from the Solana programming model 2. So we can use from the Anchor Web 3 public key find program address, we can use this function to find the PDA of the vault. So we need to use the string or the static part. This is the signer, so that's also required in the seeds. And this is the program ID. As I said, runtime will automatically use this part. So that's for the vault. And also let me add this part. So the first account is a signer. This is simple. Then we have the vault data, sorry. So like that. Then if we go back, you can see that we have new mint. And for the mint address, we can use exactly the same approach. So instead of vault data, it's going to be mint. Let's call it new mint. For example, bump m. And yeah, this is correct. So new mint, like that. The next part is the new vault. You may ask how to derive the associated address of the associated token account here. So for this, we can use, let me copy this import statement. So we can use SPL, or okay, this is just the alias. We can use this library. So let's copy it. We need to specify something like this in order to be able to use it within the TypeScript. All right. It should be resolved. Nope. Why? Okay. It is never read, so it is just a warning. And now let's derive the associated token address. Give me a second. All right, this is strange behavior. I just tested and it works, but it shows it cannot find the module. But whatever, we can continue here. So the first argument, or let me copy the arguments. The first argument is the mint for the corresponding associated token account. So sorry, let me copy it like that. So we need to specify the mint. Then the owner is actually going to be the vault data. And the last part, this true, we cannot see it because I don't know. Let me once again restart the... Okay, it's unfortunate we cannot see the description of this, or... Let me Google it. Maybe. Nope. Oh, whatever. We will continue. The first thing is the first argument is the mint that is going to that is going to the associated token account corresponds to. As I said, the associated token account address is PDA. The seeds are mint and the owner. And the first parameter is if the owner is allowed to be off the curve. Let me check. This just specifies that if it's true, then it allows the vault data to be derived or to be PDA. Okay, so we can continue. What was the name once again? New vault. And for the new vault, we want this part, this address. And we need to specify system program, token program, and associated token program. So for the system program, we can use anchor.web3. System program.program ID, and we need to specify also the token and the associated token program. So these two, we are going to use them from this library, but see again, you can see that it shows that it is not available, but you can see in the package.json we have this library. So I don't know what's wrong. Let me close this. So I will just copy these two accounts from the code I prepared. So you can take this token program from the SPL token as a token program ID constant, and same goes for the associated token program ID. All right, and we should be done here, but I also prepared some console logs so we can see the addresses. Nope, like that, like this, and put it here so we can compare them in the Explorer. All right, let's call anchor test. Oh, I didn't specify the signers. So signer 1, like that, and once again anchor test. You can see it passed. We can see the signature of transaction. Let me open the new bash and let's navigate to to the project first and then enter. And now let's call the Solana test validator and let's go to the Explorer. Let's take the transaction signature and let's have a look. Okay, it is loading. Okay. Oh, I see. It is the correct one, 35 and yeah, 35. Okay, so transaction was successful, and let me increase again the size. So we had date. We were discussing these fields already multiple times. These are the account inputs, but you can see changes in the token balances. So we minted change 1000 of tokens. We minted to this token account. So if I go back to the source code, we can see new vault. This is the mint address. So we can see the mint address here, 7 epsilon T6 is the same as here, and address is the address of the token account. So once again, we can check starts with A, so same as new vault. If we open, for example, the token, the associated token account contents, you can see this is the address, and you can see here is the mint. So basically as in the previous page, and here is the owner, and the owner starts with EQ, and that's the same as the authority, which is the vault data. You can also see that it contains 1000 of tokens, and yeah, there is the transaction history. You can also go through the contents of the transaction, so you can see what was performed. So this is just the data that were on the transaction or on the input of the program invocation. But you can see that the anchor automatically performed a CPI to the create account in order to initialize the vault data. Then this is regarding the mint account, so we had to, or the anchor automatically again create a CPI to create account for mint. Then it invoked the token program in order to initialize the mint. You can see with the 0 decimals, this is the mint address, and this is the mint authority, and you can see the type of the instruction, so it was initialized mint. We were creating the associated token account, so that's why we have also cross-program invocation to this program. And then this is for the token account. Oh, not sorry. For which account was this? Because there is this is creating the, I'm a bit confused. Oh, never mind. What we can see is that program locked, instruction get account. I want to see the greetings. Am I blind? Okay, I'm blind. Greetings from initialize. Okay, so this was the first instruction, And let's now implement the second one, which is the grep. So basically in the grep instruction, we are going to do basically similar stuff, but some kind of signer will invoke this grep instruction that will perform or that will transfer tokens from this vault to his to the signer's vault. All right, for that we need to fill this part. So first thing, we are expecting signer. Then we need to specify the mint, because this is going to be required also for the transfer. So this mint account is actually the mint account that we created in the initialize. So it will have some, we need to specify some account constraints. For example, we, in order to, for the instruction to be secure, we need to check the address, as we were creating this as a PDA, somewhere here as a PDA. So we need to check these seeds also here. Pay attention, we do not initializing currently the mint account, because it is expected to be already initialized from this first instruction. So for that part, we can skip these two fields and we can go straight to the seeds. In order to, you know what, in order to save time, let me copy this, because we can reuse it. But here are two parts that are important. The first thing is this seed is not correct because it has to be vault data. But we need to obtain the creator that we stored here, because this signer is this signer of the initialized transaction, and it was stored here as the creator. So for that, let me also copy the vault data from here and let's use it here. We are not initializing again the vault data because it is already initialized from the initialize instruction. We do not need space, we just need these parts. This signer is again because this signer can be whatever signer. So this in some cases this might be correct, not secure, but correct, because if this signer is the same wallet as this signer, then it will work. But we want to use the creator that is stored within, so like that. You can access the fields also in the account constraints. All right, so we have specified this part and also the bump. So we are just telling here, do not try to find the PDA, just use these seeds and use this bump and use it for PDA creation, so it will also save some resources. Then we take the vault data, creator, and I don't think it is necessary to have the key here because it is stored as public key, like that. And you can see, you can also specify this type of constraints. If you do not create or initialize the mint account, this will ensure that it will check if actually the corresponding mint account has these fields, such field as these values. So it will check that the mint has actually 0 decimals and if the authority is actually vault data account. All right, so we have these two parts. Now we are going to perform transfer from this vault to the user's vault. For that, let me copy this code. Again, we are not going to initialize the vault because it is already initialized from this instruction. What we need to specify, again, we can use these constraints also when we do not initialize the account. If you use these constraints, Anchor will automatically check that the address of this account corresponds to the mint and vault data or the authority. That means it will check the associated address is actually correct. What we need to also do is to specify we are transferring from this token account, and we are going to transfer to the token account which is owned by the signer. So we need to also specify this destination on the instruction input. Let's call it signer vault. Let me copy this definition and let's consider that this is also associated token account. So let me copy this part, but this time we expect the owner to be the signer. All right, and last thing that I need to specify is the token program, like that. All right, so let me sum it up. We have specified the signer. We are not initializing anything, so signer does not need to be mutable. We have the mint, seeds are correct, seeds here are also correct, bump. All right, let's take the canonical here, 0 decimals, vault data as authority. All right, what we also need to do here, maybe you already noticed, but this account has to be marked as mutable because we are going to transfer tokens from this account to this account. So both of these accounts has to be marked as mutable because the token program is going to update the balance field in this account. So that means in order to be able to update the balance field, the account has to be mutable. Okay, this should be again correct and token program. Okay, let me quickly fill this part. So for this purpose, I will borrow some stuff. First thing is this signer seeds. So let me use this thing. I'll put this also here, and greetings from grep. Okay, now the signer key. So let me again copy this like that, but this is not correct. We need the vault data like that. It does not need to be mutable, just reference, and bump is actually vault data bump, and let's take this as the creator like that. Okay, so this is taken from the initialize instruction, and now we want to perform cross-program invocation into the token program, and we want to transfer tokens. For that purpose, transfer, but not Anchor Solana program, and also not from token 2022, but use it is not as dependency here, but use from the older version of the token program. Okay, now we need the context. So let me copy this context because it is going to be pretty the same. Sorry, I misclicked. So what is going to change is this mint2 struct. It is actually going to be transfer struct like that. Let the analyzer fill the struct, and let's remove this bracket. All right, this transfer instruction needs these parameters. So from token account or from vault, we are transferring to vault we are transferring, and the authority over this source vault or over this token account. So we are transferring from okay, it is called new vault, but it is not completely new because it was already initialized in the initialize, but we just copied the content, so that's why it is called the same. We are transferring to the signer vault, and let me make this more appealing. And who is the authority? The vault data PDA. So like that. Okay, and the amount we want to transfer, let's say 10. And what is wrong here? Okay, I see. So let me use this use statement and specify it like this. So we are again using the older version of the token program, and once again we need to copy this and also propagate error. Okay, we should be done here. Let me double check from the prepared source code, but yeah, I think it is correct. Okay, and hopefully this should be also correct. Don't forget to if you do not mark this as mutable, it won't, the CPI won't be able to perform the balance updates, so it won't work. This is the signer, and let me double check, it should be correct. Let me build it. Right, and let's go back to the tests. So first thing, let me copy this test case, and first of all let's airdrop, because we have two signers, as you may already noticed. We have two signers. For this grab call, we are going to use the second signer, so signer 2. And yeah, let me remove this part like that. Let me rename this and the accounts. Okay, so for now these are going to be the same, so let's fill the accounts. So signer 2, not 1, and public key, and also don't forget to update the signers here. Then we have we have the vault data, mint, and the vault. So we can use the vault data. We can specify the mint from here, and then there is the new vault, signer vault, and token program. New vault is again the same, that this can be reused. Sorry, I need to specify like this. Now this account is expected to be token account, and more precisely associated token account. So the Solana program expects it already initialized. That means this token account needs to be already initialized prior to this instruction invocation. That means we need to create, let me remove this part. We need to create this associated token account before calling the instruction. Pay attention, this call also here, this just obtains the associated token address. This does not create the associated token account, it just derives the associated token address. As I have troubles with this, I will just copy the definition or the call let me copy also this part. So as I said, sorry, are we in the, yeah, we are in the correct test case. As I said, this call just creates or derives the PDA for the associated token account. As I said, associated address is derived from the seeds, mint, and the owner. The second call actually creates the associated token account. And for that, we need to specify the connection taken from the provider, then the signer, this is the fee payer, the mint, and the owner. So this is the first seed for the associated token address, and this is the second one. For that signer vault, we can use this signer vault, and the last part, token program, but we can take this token program from here, like this. Okay, grab account, signer, vault data, new mint, vault, signer, vault token program, and the signers. Okay, so let's test it. I think it will work because we have everything correct, but we may also want to see some of the addresses. So for example, this signer vault, let me use it like this and also like this, and now anchor test. Okay, first of all, I should stop the validator. So once again, okay, once again start the validator, and let me copy the transaction signature, and let's have a look. So like this, it is the correct one, right? Free NK and free NK. All right, timestamp. Okay, you can see the transaction passed successfully. Account inputs. But what might be more important for you is this token balance change. So we increased balance of this. This is the mint address. These are the token addresses. So this is the same address as here. So this is the signer's vault, signer's token account, more precisely associated token account. You can see it here. This is the token account of the vault data. So this first one, you can see new vault GA3. So we decrease balance here as we transfer 10 tokens out to this token account. If we open the token account, you can see 10 tokens, and these fields are, yeah, mint is basically the same as previously, and we have the second owner. And yeah, you may also find interesting this part, so you can investigate the transfer instructions. So you can see that we are transferring 10 tokens. This is the token program address. Sorry, no, this is the mint address. You can see it here, and yeah, once again we can see it also here. So 0 supply, 0 decimals, 1000 supply. I would say this is pretty self-explanatory and simple, but you can see the transfer do not actually change the supply. The supply is still the same, but the distribution is not in one token account, but in 2 token accounts currently. So if I go back, and yeah, you can also check this account, but these accounts, but this is the authority. So this is the PDA, destination, and the source. So the signer's vault account and the initialized vault account in the initialize instruction, and we can see greetings from grab instruction, and everything was successful. So yeah, everything was smooth apart from that. I'm not sure why it cannot see the module, but whatever. Hopefully you understand what is happening here. if you try to develop this locally and you hover over this instruction, you will see a description and what are the parameters. Same goes for this instruction. So if you're not sure, feel free to ask or Google it. I do not want to waste time right now Googling and finding the description of this call. Yeah, so that's everything. Hopefully it was understandable. This is just example how you can use tokens within your Solana programs. So you can see mints and tokens can have mint authorities set for PDAs. Same goes for the vaults as we were doing here with this vault. And you can see you can also initialize the mints and also the token accounts in the instructions, or you can expect that the mints or the token accounts are already initialized as was shown here in the second instruction. So yeah, this is everything from the hands-on example, and now let's go back to the slides. This is all from this lesson. I hope you enjoyed this hands-on example. As I said, you can utilize the mints, or it is highly recommended to utilize the mints in the Solana program, so you will learn a lot of new stuff. And yeah, see you in the next week during the next lesson. Bye.